Hello class! In this video I'm going to do something a little different. I actually gave this presentation to my son's Cub Scout troop just a couple minutes ago, but I thought it was fun, so I thought I'd record it and put it up online. It has to do with the Pinewood Derby. Doesn't really have much to do with architecture, although if you stick around to the end I will mention architecture at the end of this video, as I did for them. So basically I was asked by the troop to talk about the science of Pinewood Derby and to make a fast car. And if you don't know, the Pinewood Derby is, I'll just show a couple cars here. You get these wood blanks from Cub Scouts and you carve it up, you get the wheels and everything from them, and you race it down the track, and whoever is fastest wins, and so on and so forth. That's a simplified version of it. And so, even though I was asked to talk about the science of creating a fast car, I actually started with a magic trick. So I'm going to start you guys off the same way. And we can see I created this ramp over here because the Pinewood Derby is based off of ramps. And we can see there's a little ramp here. This side is definitely higher than that side. On that side. So I'll put this down here on my table just to prove that it's a ramp and it works the way ramps should work, and gravity will pull things down. I can put a dowel on it and it rolls right off like this. But here comes the magic trick, because what I'm going to do is I'm going to take this guy here, I'm going to put him on there, and woo, it rolls uphill. That's my magic trick. Of course it's not magic, it is science. And the principle that makes this work, I would argue, is the most important thing you can do to make your Pinewood Derby car faster than your competitors. And we'll get back to that when I need to talk about it. But I want to talk about what I'm going to talk about in summary here. So I'm going to do a bunch of experiments to show all these concepts. But in summary, I like to think that there's three most important things you can do to make a Pinewood Derby car go fast. First is aerodynamics, making your car shaped like an arrow. It's a simplified version of it. Two, making your car as heavy as possible, which Cub Scouts rules say 5 ounces, so you want to be right at 5 ounces. And the third is that to put all your weight, or most all your weight, 1 inch in front of the rear axles. Right? And that's called your center of mass. And we'll talk about why all of those things are important. Again, if you've done the Pinewood Derby, you know that basically the way the track is set up, there's a big long track that goes uphill, and then a big, even longer flat. So the cars run down the hill with gravity, then they just coast to the finish line. The person gets there faster. So I've created a modified version out of cardboard and some extra wood here on my surface. And I'm going to talk about these three principles of a fast car based on 3 points of the track. The first point is the slope of the track. Again, real Pinewood Derby, much steeper, much slower, but for our model, this will work. The second part of the track is actually the transition between the sloped part and the flat part, and then of course the last part will be the flat part. And I'll relate each of those 3 principles of the car to a part of the track. Right. So as I mentioned before, the first thing I want to talk about is aerodynamics, and I think, while it's important for the whole track, it really is most important for the sloped version, or the way the race starts. And so to talk about aerodynamics, I'm first going to start with this experiment over here. So I've got a feather here. If you look closely, it's actually just a piece of paper cut like a feather, and this ball made of clay right here. And I'm going to hold them up here, and if I drop them, I would ask you to think which one's going to fall to the table first. I think everyone probably got the answer correct, which was that the feather took longer to hit the table. The ball hit the table first. So when I met with the kids earlier this evening, I then took this ball. This was the ball I just dropped. I took the second one, which is approximately twice as big, and I hold them at the same height. And I can ask the same question, like, if I drop these, which one is going to hit first? Now, they end up hitting at the same time. Now, you may have known that, but a lot of folks would think that actually the big ball is going to hit first. And their thinking is, well, the feather hits the ground after the ball, and the ball's heavier. Well, this big ball is heavier than this ball, so this is much going to hit the ground first. But it's not true. Actually, gravity pulls everything at the same speed. And the reason why I'm talking about gravity and speed is because all your energy for a Pinewood Derby comes from falling down this ramp right here. So the scientist who really began to realize that gravity pulls everything at the same speed was Galileo Galilei. And I want to walk you through his thought experience of how he concluded this. Now, he did prove this with a lot of physical experiments as well, But he first started to think about this in his mind. He's going to get some tools here. If I start with two balls, these are the same balls, two of the same size. No one would question that if I drop them both, they hit the table at the same time, right? That makes sense. Well, I can take them from here, from holding them side by side, and I can just move them to here. That's pretty much the same experiment. If I drop them now, even though they're closer together, they're still just two balls. One almost got away here. They're two balls, same size, they drop at the same speed. But this is what he thought to himself. He said, okay, well, if I start here, they drop at the same speed. If I move them here, closer together, they drop at the same speed. Well, if I keep moving them in the same direction and smush them together, they're still just the same two balls. They drop at the same speed. So when they're together, they will continue to drop at the same speed. And in essence, this is two balls, and this is two balls. They will all fall at the same speed. All objects fall at the same speed. Now, there's a big caveat to that, of course, which is because I already showed that the feather doesn't fall at the same speed. So why does a feather not fall as fast as a regular ball? It has nothing to do with its weight. It has everything to do because this feather floats on air. It's not aerodynamic. These balls, circles, spheres, whatever you want to call it, they're pretty aerodynamic. They push through the air quite quickly, even though it's falling at the same speed. This does not. And so that's the first principle. As we're looking at the hill, let's take this to the track. So I have these sort of modified cars. These aren't real Pinewood Derby cars. I just have a bunch of these for my experimentation purposes. And I've got one here, it's the green car. It's going to be my light car for now. And I got the red one, and it's heavy. And you know it's heavy because I put this wooden cone on top of it that adds weight to it. And the way that the race starts is they both start at the same spot at the top of the hill. Actually, our track, I don't know if they have different size tracks, but our track in our group is actually 3. You can get 3 cars on, but we're going to work with 2 here. And based on the rules I just told you, that if I let go of these 2 cars, even though the red one's heavier, they will fall down the track. Gravity will pull them at the same speed. So I'm going to have that metal ruler there to stop them. But if we pull them down, we can see almost identical. They hit the ruler pretty much at the same time. So weight is not the issue. But some cars can get to this point faster, and they do so because they're more aerodynamic. And I'm going to just modify this green car here just to show what I mean. I'm going to put this big sail on the car. I'm going to slide over here for a second, bring the cars back up to the top. We can see that the sail, not being aerodynamic, made the car go a lot longer. Without the sail, they went down the ramp at the same speed. With the sail, the air stopped it and slowed it down. So an aerodynamic car is a faster car on the first part of the slope. Now you might be asking yourself, what does aerodynamic mean? You know, for the Cub Scouts, I basically said something shaped like an arrow, starting narrow and getting wider towards the back, something streamlined. You can think of most cars are aerodynamic to some point, at some point. So something like an arrow and streamlined is the way you want to go. You'll notice most Pinewood Derby cars, and I've got a couple examples I'll be using today, they start skinny up the front and they always get wider in the back. And the reason for that is most cars that are fast will use some weights in the back of the car, and we'll get to why you have to get to 5 ounces before the end of the video. But the reason why you slope up is because you got to put the weights in. You got to have room for that. Otherwise, you just make a flat car, which would be the most aerodynamic. And actually, another technique, there's lots of ways of making cars aerodynamic, but another one is this one here, which is not having any wood at all. If you can actually get rid of wood, the car will just be faster and more aerodynamic. But again, where I needed some wood to get my car up to its 5 ounces, we get a nice curved slope right there. Aerodynamic shape. And there's other versions. I've got another one here that we made just really quick to talk about aerodynamic. Same basic shape though, skinny up front, wider in the back, has some curves. This one's nice, fast, red, and fire. So an aerodynamic shape is a fast shape for the beginning of the race, because gravity will pull at the same speed. All right, let's move on. We're going to talk about the second part of the race, which is the transition between the slope and the flat. By that, what I mean is, if this is starting the transition here, the front of the car hitting the flat to the back of the car hitting it. It's a short segment of track. That's all the length of track I'm talking about. Yet, in this short segment of track, it's where you can probably get the most advantage over your competitor. And the reason for that is because, as I mentioned, we're getting all our power from gravity. And this is the one point of the race where you can get more power or energy out of gravity than any other place. And the way you're going to do that is by making your car fall further than your competitors. And you might be asking yourself, it's the same track, going the same way. How is one car going to fall more than the other? If every car starts here and every car ends here, they're going to fall the same amount. That's true for the car, but what really matters in this case is the concept called center of mass. And the center of mass can be different based on different cars. And so let's talk about center of mass really quick. I showed this rod earlier, and if I hold it with 2 fingers, I hold it like this, no one's surprised that my hands can hold it up on the ends of the pieces of wood. But as I can also pull my hands in slowly all the way to the center and have them touch. And the rod still does not fall. Even though there's a lot of wood on the left-hand side and a lot of wood on the right-hand side, all the mass can be thought of as if it's right at that one point in the center from a physics standpoint. Now, if I'm really good, this is a bit tricky, but if I'm really good, I can get this rod to balance even on one finger right on that center point, right? So all the mass is concentrated right on that point, right in the center. In fact, the concept of center of mass is actually what made this magic trick work over here that I did earlier. And the thing is, the center of mass of this double cone is in the center of this object. And the reason why this works, why it rolls uphill or seemingly rolls uphill, is because if I keep this one here, but I have a second version, if I put it at the start here, if you look really closely, what you'll see, even though the ramp is moving uphill, notice that these cones, this cone over here is lower than this cone on this side. And so when I let go, even though it's going up the ramp, it's actually falling down. It's all about controlling center of mass and making sure you sort of get the most out of the gravity as you need to. So let's take that concept of center of mass and bring it back to the cars. So I need to get another car example, which fell off the table, so I need to go get it. So I have 2 cars here. I've got the red car, I've got the yellow car. Both have cones on them. They're both the same weight. We know whether they're the same weight or not. They will basically end up at this point at the same time because gravity will pull them equally. But because this cone's in the front and this cone's in the back, it means that the center of mass is in different spots in these 2 otherwise identical cars. The center of mass here is up at this cone. The center of mass is back here at this cone. It's actually the point where all gravity is pulling. So they started at the same time. They got to this point at the same time. But look at this. This yellow car, the center of mass is pretty much at the bottom of the ramp. In fact, if I just pull this back slightly, we can put it there. So this car is now at the center of mass is at the bottom. Gravity will not affect that cone at all. It will not pull that car. But look at this red car where the center of mass is here. This is still on the ramp. This red car can still fall because this will still be pulled by gravity until the car gets to here. So if I just jump the ramp slightly, I can get gravity to pull this car all the way for the red car to be up in that front. And that little bit of difference is very minor, but the little bit of difference will make this car go faster in that transition. It's the only time period where you can get more out of your car than your opponent. So let's take a look at this. I'm just going to set this back up on here. If we look closely, this might be subtle. It's very tough, but if I remove this barrier, because this cone has less to fall than this cone, the red car should go a little bit faster and probably a little bit further than the yellow car as well, proving that the center of mass does control how fast it goes. So you can see, again, very subtly there, but it did work. All right, so let me take this car, and I've got one more car for you. I've got this blue car here, and you see this blue car, I have the cone way back, almost hanging off. The weight is as far back as possible here. And so if we're based on our past experiments, then maybe this will have a higher center of mass, it's further back, and maybe we'll go even faster than the red car. Well, let's see what happens. we can see what happens is the car becomes unbalanced. And while you do want the center of mass and the weight as far back as possible, because it's on wheels, it sort of acts like a seesaw. And if you put your weight behind the rear axle, it will tilt, it'll be unbalanced, and it'll generally be slow. It might not quite go crazy like I've shown it in a real Pinewood Derby car, but it will make it slower. And so you want to keep your weight in front of the rear axle. About an inch in front is what the numbers experiments showed to make it the fastest. That is the third stage, and I would say that is the most important. But let's move on to the last stage, which is the big long flat. And to talk about the big long flat, what I want to talk about is actually Isaac Newton, who also studied gravity and certainly simplifying these things a bit, but he had his 3 laws of motion. I'm going to talk about a couple of them here. And his first law of motion says that an object in motion will stay in motion unless acted upon by another force. And so we know that the car is going to be moving down the hill. Let me just put this guy aside. I don't need him right now. We know this car is going to be moving down the hill, and it's got speed. Once we got to here, there's no more gravity on it, so no speed will happen. But according to Newton's laws, this car will keep going unless it has another force on it. And that's why there's a long track in the real Pinewood Derby where it'll go, it'll just coast, and that's because of Newton's law. But we all know that it won't coast forever, right? And so the question is, what makes it slow down? And it's not too hard to figure out what makes it slow down. What makes it slow down is the fact that it has to move through air, and air is pushing on it, creating a force, and also there's friction between the wheels and the table or the wheels and the track that also creates heat and a force, and that just takes the energy out of the car, and so it slows it down. And so what we want to do is we want to make sure the car slows down as little as possible. So if the air is pushing on it and the friction is essentially pushing on it, we want to make sure our force of the car is as strong towards the finish line as possible. So that brings us to Newton's second law, which is force equals mass times acceleration. Again, to sort of simplify things, you can think of that as really the force is equal to its weight times its speed. Now, we already talked about the speed of the car because we set it up here. We talked about how gravity pulls it down and how we can use center of mass through this zone. But once you get to here, you cannot get any more speed out of it. Speed is beyond our control. And so this is really the spot where weight becomes important. The heavier your car, the more force it will have to push itself through the air. Heavier cars will be faster. All right, that's why the Cub Scouts actually limit it with the rule. They say a car can only be 5 ounces. You want to get your car as close to, or really right at that 5-ounce mark, so that you can get the most force out of it. So let's run another experiment. What I'm going to do is I'm going to take these blocks over here, and I'm going to put them here. And these blocks are meant to sort of be like the air molecules. If you don't know what air molecules are, basically everything. The world is made of atoms, and atoms are the building blocks of all matter or objects. So we can't see them, they're so small, but they are there, and the car has to run through them. So let's pretend that we make these air molecules, these air atoms, very big, and we're going to pretend they're these wooden blocks. What I'm going to do is, I'm going to take this car here that I used earlier, take the sail off just because it's my lightest car, and I'm going to roll this down the hill. There we go. And you can see because it's light, it doesn't have a lot of force. It has a lot of speed, but it has very little force because it's not heavy and it can't push through the air very well, or these blocks. So let me grab one of my heavier cars, which is a real Pinewood Derby car. And if I start at the same spot, it's going to reach these blocks at the same speed because gravity's pulling it equally. But it's a lot heavier, and you can see that it can push right through the air. So your weight wants to be 5 ounces. That's going to help you coast the best, right? So those are the 3 big principles, and let me just review them again for you. I'm going to move these out of the way. So, number 1, you want to be aerodynamic, or sort of shaped like an arrow, low profile, right? You want to be at the 5 ounces, so you're probably going to have weights on it somewhere. But most importantly, most of your weight, or your center of mass, wants to be 1 inch in front of the Pinewood Derby car. Which brings me to an important point about the design of your car. I'm just going to show this one because it's nice and red and we can see it. The Pinewood Derby cars, they come as square blocks, but they don't come symmetrical. They come pre-drilled with the axles for the wheels, and you're not allowed to change them. They have to be that width and in those locations. But you'll notice that on one side, there's like 1.5 inches between the end of the block and the axle, and on the other side there's only like a 1/2 inch or so between the end of the block and the axle. And you want the weight as far back as possible. So you want the weight as far back as possible. So you need the axle as far back as possible. So you want it so that the rear axle is on the side that has less side of wood, and the front of your car is the side that has the most amount of wood between the block and the axle. So that's an important tip for the Pinewood Derby too. And there's other factors that can make your car go faster. People put graphite on their axles, which are just nails. They make sure that their axle's at a particular angle and all these things, and those things probably add speed too, I think, to a minor degree. But I think actually one of the things that can really combine with all the principles I talked about today is probably craftsmanship. Making a really nice car is important too, and I don't have a wood shop, so I just have hand tools and things. So my cars are certainly not the nicest, and I can certainly be beat in that regard. But before I end this video, I do want to say one thing that I told the kids this, which is, this was a very functional discussion. It was about science and the engineering of making cars go fast. But I'm an architect, and I don't only just think about function. Right, so design is just as important as function. In this case, it could be making a really beautiful, interesting, creative car. So I encourage everyone to do that. That beauty, interest, creativity is just as important as speed. In fact, just really quickly, I was going to show a car I found that I made when I was about my son's age. And I wanted to make it look, I thought it'd be cool to make it look like an old-timey race car. It was not fast. You can see it even breaks the principle that the rear wheel is sort of too close to the front, so I can't get the weight proportion right. It's not very aerodynamic, but I thought it looked cool. And so that's also just as important. So I hope everyone enjoyed this video, maybe learned something about Pinewood Derby, and see something else that I typically do in my life. Thanks for watching.